Okay, so in this section, we're going to talk about compound inequalities. All compound inequalities are is this. They are two inequalities put together. Okay, so remember, inequalities are anything with the symbol less than or equal to, greater than, or greater than or equal to. When we're dealing with compound inequalities, it's basically just too many questions in one. The key thing about compound inequalities is that there's two different types of compound inequalities. There are and compound inequalities and there are or compound inequalities. Okay, so what's the difference? So like we said, a compound inequality is when two inequalities are put together. And if you're dealing with an and compound inequality, it's got to meet both conditions. Okay, it's got to. So for example, we see the example listed here is 10 is less than or equal to 3x minus 2, and it's also less than or equal to 4. Whatever x is in this scenario, it's got to meet both requirements for both of these numbers in order for it to be in the correct interval. Okay. In comparison, an or compound inequality just means you have to meet one or the other condition. So the example we have listed here is 4x plus 1 is less than 2 or 7x is greater than 14. Okay, so if you were to go through and solve this, you would get two different equations, and in order for it to be a true statement, you just need to be in one of those intervals or the other. Okay, you can meet the first or you can meet the second. Okay, so let's do some examples. So we're going to start with a word problem or just like reasoning through it based on what the scenario says. It says all real numbers that are greater than 0 and less than or equal to 4. Okay, so let's break this down into its pieces. We're looking for the interval of all real numbers that are greater than 0 and less than or equal to 4. Okay, so let's choose x as our variable. X is the magic variable we're going to pick, and let's write each of those statements. The first thing we see here is x has to be greater than 0. Okay, how do we write that? Greater than, the alligator is going to eat the x, and 0 is next to it. X is greater than 0. Okay, that's the first condition. The second thing it says is also x has to be less than or equal to 4. So what does that look like? Okay, I'll always start with x. And less than or equal to means my alligator is going to open up to the right. Less than or equal to means I got to have a line underneath. And it'll be less than or equal to 4. So in this statement, I need both things to be true. I need the first and I need the second. Okay, so let's see what this looks like on the graph. So 0 would be over here and 4 would be over here. 0 is less than 4, so 0 is to the left of 4. Okay, if we wanted to do the shading here, what would it look like? So if I look at the first statement, it's x is greater than 0. When I see that symbol for greater than, there is no line underneath, so that means I'm going to have an open circle at 0, and my arrow is pointing to the right. So I'm going to shade also to the right, and that shading should go on forever and ever to the right. Okay, but what we notice on the other side is that whatever this number is, it also has to be less than or equal to 4. Okay, that's a completely different statement. But let's try to graph it on the same grid. Okay, if my interval needs to be less than or equal to 4, I'm going to have a closed circle at 4. And I notice that my arrow is pointing to the left. So what does that mean? Starting at 4, I'm going to shade to the left. Okay, and what we start to notice is that there's going to be some overlapping area. Okay, so because we're looking for an and compound inequality, we need the space in which both of these conditions are met. What are the numbers that are both greater than 0 as well as less than or equal to 4? okay? And it's gonna be that area where the yellow and the purple collide. This is my sweet spot right here. Numbers that are bigger than 0, but less than or equal to 4. It's numbers like 1, 2, 3, and 4 would be in the interval. Anything in this sweet spot right here, okay? So do you think and compound inequalities, you're thinking, okay, where do the shades collide? Okay, for example, B, we're looking for all real numbers that are less than -1 or greater than 2. Okay, so let's break down that statement into its pieces. We're looking for the interval where all real numbers are less than -1 or greater than 2. Okay, let's use x once again. The first thing I see here is x needs to be less than -1. Okay, less than means the alligator is going to open to the right with no line underneath, and it's going to be -1. The second thing I see here is the other option is or x could be greater than 2. Greater opens to the left, could be greater than 2. Okay, so what are the options here? -1 is going to be closer to the left, that's the smaller number, and then 2 is going to be closer to the right, that's the bigger number. 2 is definitely bigger than -1, so it's to the right of -1. Okay, let's graph both of these equations or inequalities on the same number line. So we'll start with the -1 one first. X could be less than -1. If it's less than, it's going to be a open circle, and I'm going to shade, the arrow is pointing to the left, so I'm going to shade to the left. Okay, it could be any numbers that are way, way to the left here. Numbers like -2, -3, -1,000,000. All of these numbers classify as numbers that are less than -1. Okay, but that's not the only option here. I could be way, way to the left, or another option that would work is I could be greater than 2. What would greater than 2 look like on the number line? Okay, it would be an open circle at 2, and my arrow is pointing to the right. So I'm going to shade to the right. Okay, so what are the two options here? It's not going to be able to meet both conditions, but I could have a number that is really, really small, really, really negative, and that would be just fine. Or I could have a number that's bigger than 2, and that would work just as well. Okay, numbers like 3, 4, 5, 6, 1,000,000, all of these numbers way out here would work. The only numbers that don't work are the numbers that are in between -1 and 2. Numbers like 0 or 1 or exactly 2. Okay, 2 is not greater than 2. It's not included in the interval. Okay, so what's the takeaway? And you need both conditions to be met, or you need one or the other condition to be met.